Today we are going to start the topic of size of antenna, or we call it as aerial 2. Every communication system employs antenna. What it is basically? It is a length of a conductor that acts as a conversion device. So what is antenna? It's the length of conductor. And what is its work? That acts as a conversion device. All the communication at the transmitter as well as at the receiver employs this antenna. At transmitter, antenna converts the electrical signal into electromagnetic waves. On the other hand, at the receiver, its opposite is going to happen. Receiver end, the antenna receives these electromagnetic waves that are sent by transmitter into the free space. At the receiver end, the antenna intercepts the incoming waves and it converts those received electromagnetic waves into electrical signals, and then it feeds those electrical signals to the receiver for the circuit. So this is what antenna is doing. Now we want our communication should be very efficient. To have that efficient uh, transmission, reception, we want that the antenna must work at the resonant frequency. The antenna requirement is to work at the resonant frequency of that circuit. Of that circuit means communication circuit that we are employing. To have this, we want that antenna must be of the length of lambda by 4. Now, for efficient transmission and reception of the waves, it is found that the length of antenna should be 1 by 4th times the wavelength of the radio frequency signals employed in the circuit. It means this thing that length of antenna is equal to lambda by 4, where lambda is the wavelength of radio frequency signal employed in the circuit. One more important conclusion can be drawn from here, that we know that this wavelength is inversely proportional to frequency, since lambda is inversely proportional to the frequency. Here the frequency is of this RF signal employed in the circuit. So lambda is equal to C upon V, where C is the velocity of light, that is 3 into 10 power 8 meter per second. Now we found that if the frequency of this RF signal is more, then lambda will be less, and if lambda is less, then length of antenna required will also be less. So it is concluded that length of antenna decreases with increase in the frequency of carrier wave employed for communication. Several types of antennas are employed for the communication system. Uh, Here are the types of antenna. Dipole antennas. Dipole antennas, basically, this antennas classification types are depending upon the directions it is going to cover. These dipole antennas are omnidirection. Omnidirection means in all directions. On the other hand, there are dish antennas. They are highly directional. Highly directional means they are particularly focused in a particular direction. So depending upon the requirement, the types of antennas can be selected for the type of the communication that is required. So generally, instead of asking the direct article on length of antenna, maximum times a number of numericals used to come on the topic. Here I have taken a numerical, calculate the required lengths of dipole antennas for carrier waves of frequencies. A part is 30 megahertz and B part is 300 megahertz. So let us take the first one. Here given is the given frequency of carrier wave is 30 megahertz. And we are required to find out the length of antenna. Let L be the length of antenna. Now we have found that formula for this length of antenna is equal to lambda by 4. We are having frequency, not the wavelength. So let us first find out the wavelength. To find it out, we know wavelength is equal to c by nu, where c is the velocity of light, that is 3 into 10 power 8 meter per second, and the frequency given here is 30 megahertz. So let us put these values, 3 into 10 power 8, and because it is an SI system, so let us take this frequency 2 in the SI system. This comes out to be 30. Megas tends to 10 power 6 and hertz is in per second. So we'll put this value here, 30 into 10 power 6, and this comes out to be, after cancelling, 10 meter. Now we found the wavelength. The required is length of antenna. Now we will put the value of lambda from here, 10 meter, in this equation. So L is equal to 10 by 4, that is the length of antenna required is 2.5 meter. So for 30 megahertz, the length of the antenna required comes out to be 2.5 meter. Now let us calculate for the next frequency, that is 300 megahertz. Now let us see the second numerical where the carrier wave frequency is given 300 megahertz and we need to find out the length of the dipole. Now here is a given frequency. We have taken 300 megahertz, convert that into the hertz by taking the value of mega 10 power 6. This is 300 into 10 power 6 per second. Now the wavelength is given by velocity of light upon the frequency. So putting these values, we find out that lambda comes out to be 1 meter. Now the length of antenna, that is 1 by 4th of the wavelength, and we found that the length comes out to be 0.25 meter. So for 300 megahertz, the length of the dipole antenna required comes out to be 0.25 meter. So here you can find out these things, that we have taken one important conclusion, that as the frequency of the carrier wave increases, the length of antenna decreases. And here it is 30 megahertz, required length of antenna is 2.5 meter. As the frequency of the carrier wave is increased to 300 megahertz, in that case, the length of antenna, just see, it has decreased to 0.25 meter. So this is all about the length of antenna or aerial for today's talk. I am giving you one question for practice. This question has come in the CBSE exam. What should be the length of a dipole antenna for a carrier wave of frequency 6 into 10 power 8 hertz, and given is the velocity of light 3 into 10 power 8 meter per second? Note down the statement of the question and find out the answer for it. Give your answer in the comment box. So this is all today for the size of antenna or the aerial.